Hey guys, welcome back to our JavaScript series. In this video, we are going to talk about the difference between let, var, and const. Now, you already know that let and var both are used for creating variables, whereas const is completely different and it's used for creating constants. But what if you want to create a variable? Now, if you want to create a constant, it's a very simple choice that you have to use const. There's no other option you have. You can only use const for creating constants. But when you want to create a variable, then you have two options with you, let or var. Now, for those people who are new to JavaScript, you might think that, okay, we can use them interchangeably, right? But that's not true. See, there are some differences between let and var. Now, if you want a short answer, I will say that you have to use let instead of var because let has some advantages over var. But I would actually recommend you to watch this full video to understand the difference in detail because whatever we're going to talk about in this video would not only tell you about the difference between let and var, but would also be very, very helpful uh, when you go through this whole series, right? So that's why I would recommend you to watch the full video. And so let's get started with this video. Now, first of all, let's talk about the difference between let and var. For that, we have three differences. The first difference is that var has no block scope. Now, for understanding this, you should have an understanding about blocks in JavaScript. So if you don't have that, you can watch the lecture 10 uh, in the JavaScript series, and that would teach you about that. But anyways, let's open a Core.js file and let's talk about it there. So basically, you know that if I create a variable a here and give it a value of 1, let's say, and then just go and print the value of a, that would work fine. Okay. So I created this variable in global scope and I access the value inside the global scope itself. Now, let's say if I create a block here. Now, if I try to access the value of a inside this block, that would also work because you can access the value of a variable or constant that is declared outside the block and it would just work fine, right? But if you're going to create a variable b here, for example, with a value of 2, you can go and access that value of b inside the block, right? Even inside a nested block inside that block, you can do that. But you can't access the value of b outside the block. That is what we understood in blocks lecture. I told you about this, that blocks in JavaScript carry their own scope of variables and constants, which means if you create a variable or constant inside the block, not just variable, if you create a constant as well inside the block, they would only be accessible inside the block. You can't access them outside the block, which is what is happening over here, right? B is not defined outside the block. But the story will be different when you talk about var. Let me show you an example. So let's say I create a variable with var called c, and I go and give it a value of 2, let's say. Actually, let's give it 3. Now, if I want to access the value of c, I can access it here, which should be fine. In the global scope, I'm able to access because I declare the variable in the global scope. And if I want, I can access the value of c inside the block as well, because block can access the value of variable or constant declare outside the block, which is fine. And here also I would be able to access the value of variable c, which is also fine because I'm accessing it in global scope. Now let's say if I create a variable again with var inside the block called d, and let's give it a value of, let's say, 4. Now I can access the value of d inside this block, and even inside this nested block I can access the value of d, which is all fine and which makes a lot of sense as well, right? But what will happen if I try to access a value of d outside this block? Now, you already know that block carries its own scope of variables and constants. So you might think that if you try to access the value of d outside this block, it would cause d is not defined error. But the reality is different. If you try to do that, you can see you are able to access the value of it. Why that is working? Because var has no block scope. Okay, which means you are able to access the value of a variable created with var inside a block outside that block as well, because block won't have any kind of effect on that variable. Okay, And that is one of the disadvantage of var. You can't have a variable that doesn't care about the outside environment uh, in the block, right? You can't do that kind of stuff, which is possible with let or const. So that's the first thing. Let me just take it here. Now let's talk about the second thing, the second difference. Second difference is that var doesn't care about redeclarations. It tolerates that. Now let's take an example here. Let's go and say let a equal to 4. Now if I do that, if I go and create a again, you can see I get this error. Cannot redeclare block scoped variable a. Okay. Now this error makes a lot of sense because I already told you that you can't have variables with same name, variables or constants with same name inside the same block. That's not possible. And the same would happen with constant as well. If I create a constant called b with the value of 5, and then I just created a constant again called b with a value of 6, again, that won't work. Okay. So that's the thing. You can't do that kind of stuff because let and const doesn't allow you to redeclare a variable or constant again, right? With the same name. But that's not true with var. If you go and say var c equal to 7, now if you say var c equal to 8, you can see it's working fine. Now you might ask, what's the final value of var? Final value of c. So if you go and say console log c over here, it would give you 7. Here it would give you 8. So you can see basically what's happening is that this line creates a variable c and this also creates a variable c. But basically because c already existed, it replaced the value of c with 8 instead of the old value of 7, right? And that is what is happening over here. You can see var is allowing you to redeclare variable, right? Now that might sound convenient, right? That you can just go and use same variable name throughout the program. But when you actually write complex programs, you would actually understand the issues with this thing. This has happened a lot of times with me that what I do is that I create like two variables, okay? And those two variables are basically storing two different information. And I would be accessing those two variables throughout the whole like program, right? Problem is that let's say those two variables were created with var, for example, and by mistake I gave them the same name. In that case, hopefully you can understand it's going to cause a bug because I would be expecting that that variable would have the value, the first value as well, like basically like I would have two variables basically at that point. That's what I would expect, but that's not true. This is allowed by var, but that can cause a lot of issues. And that's another disadvantage with var, that you can redeclare. That's a big disadvantage, right? You might not feel it when you're writing like short programs, but you might start feeling it when you're actually writing big programs where you would see if this happens, that's going to cause a lot of trouble for you, right? It can cause some unexpected bugs that you won't be able to even understand without debugging it properly. Next thing here, which is very important thing, is hoisting. Now, for basically those who have watched the function lecture 13, I talked about hoisting there, but let me actually talk about it again in a detailed way actually, right? So see, the thing is that let's say you create a variable or constant, okay? Let's say I create a variable, or let's take in a constant this time, okay? And by the way, everything I told you here and here would apply on constants as well, so don't worry about that. So see, the thing is, let's say if I just go and create a constant here, let's say a, and give it a value of 4. Now, if I try to access the value of this constant after this one line where it's actually created, it would give me a value of 4, which is all fine. I can access the value of this. But what would happen if I try to access the value of this constant before this second line? Now, basically, if you try to do that, you might expect that would give you an error, which is good, which is what it's going to do, right? It would give you an error that cannot access a before initialization. Okay. But let's take an example of var here. Let's say you create a variable called b with var, and you gave it a value of 6. Now you went ahead and said where you just printed the value of b, and that gave you 6. But what would happen if I try to print the value of b, or maybe access the value of b before this line 6? Now your answer might be again like it would give you an error, cannot access b before initialization. That's what you might expect. But the reality is different. You won't get that error. So basically, if you try to do this, you would get a value of undefined inside b. And that is what is called hoisting. That's why you are able to do this, right? You are able to access the value of b before it's initialized because of this reason. Okay? Because the variable created with var are hoisted. Now, to understand this, just think about it in this way, that when you're creating a variable with var, then JavaScript would basically, in a way, not really, like it's not really going to do that, but in a way, what it's doing is that it's basically moving this thing away, and it's just, taking this at the top and saying var b. That is what it is doing essentially, right? It's declaring the variable before the rest of the program executes. And when it reaches the initialization line, it gives the value to that variable properly. Okay, that is how you can understand hoisting is working, right? It's basically declaring that variable already so that you can at least access the value inside that variable. Okay, I mean, you can like basically reference that variable. That's what you can do. At least that's what you can do. But you can only get the real value of that once you reach the line where it was initialized. And that's what hoisting does. Okay. Now, one more thing here is that if I go and say var c equal to, let's say 8, and I go and say console log c, that gives me 8. Let me just remove this. Yeah. And then if I go and say console log c over here, that would give me undefined as we saw. But if I say c equal to 9, you will see it's giving me 9 over here and 8 over here. So you can see that not only we can access the value of that variable before its initialization, we can also change the value inside it. Okay. But obviously that would reset the value once you reach the line where it is initialized. Okay. Again, that's happening because declarations are already done, and that's why you were able to change the value inside it and get the value of 9. But after it reached the 11th line, it got to the initialization stage and then got a value as well of 8, which was the original value that would have been there, right? And that's the thing, that's called hoisting. That's what happens, right? And I told you about this in functions lecture, that functions are also hoisted. Basically, that means that you can create a function like this, add, and if you go and say like a b, and you go and say console log a plus b. So if I go and say add 2 3, that gives you 5, which is good. But you can access the access basically the add function before the add function declaration as well. You can just say add 2 3, and that would also give you 5 here, because like obviously you can access the add function before the declaration, because these function declarations are also hosted. The only difference you can see here is that when variables with var was hoisted, then the variable got a value of undefined, but in this case you were actually able to access the function properly because the whole declaration was hoisted, right? Now if you just go and like maybe like say let add with let, and I just go and say a b, and then I just said a plus b. Now if I do something like this, if I try to go and say add with let and I say 4 5, now it is printing value, but because of bug it is only going to show you that in the console here. You can see, right? So maybe I can just go and like actually first of all I should make it a plus b, right? Anyways, let's go and like put it like this so that it at least prints the value. I can see it prints 9 here. Okay. But what would happen if you try to call this function over here? Now, again, like you know that let and const are not hoisted, which means you would get a reference error that you can't access that before initialization. let me try that, add with let. And if I say 4, 5, you can see cannot access let, cannot access add with let before initialization, which makes a lot of sense, right? So you're getting a reference error over here, which is what we expected. Now, if you try to do this with var, so add with var a comma b, and then you said console log a plus b, and then said add with var 6, 7. Now you can see this is working fine. Now you might expect that if you try to do it over here, that would also work fine. But the thing is that won't work fine. Now it won't cause this error, like cannot access add with let before initialization, but it would cause some other error. Let me show you. If I say add with let, add with var, sorry. If I do this, you can see I'm getting add with var is not a function. Now that's a complete different error than the above one. Why this is happening? This is happening because you already know that when var is hoisted, var gets a value of undefined. And that is the reason why this thing is happening. Because at this point, the value of add with var was undefined. And so undefined is not a function, which makes a lot of sense, right? Like you can't go and call undefined here. And that's why this was happening, right? Let me actually go and say add with var here, and you can see it's printing undefined. That's the thing. So function declarations get hoisted completely with the function code as well, but that doesn't happen in case of let and var. Okay, I mean let doesn't get hoisted at all, and var gets hoisted, but basically like it gets a value of undefined. Okay, now that's the thing with this. I just want to prove this, and for that I can actually show you the debug section here, which would actually prove everything. Okay, let me go and do all this. Like I'm just going to mark all the lines here as a breakpoint. Now let me go and say here and run and debug. I select node.js over here, and that starts the program. Now see a very interesting thing over here. You can see that I'm on this line, right? I'm on the first line. But if you see the variables over here, you can see that we have the add function with the whole declaration, like everything. Basically, the whole function code is there as well. This is completely there. And so I said, that's why I said it's hoisted. It has not even reached this line of function declaration, but still it's there inside the memory. And that's why I was saying it gets hoisted, right? The same goes with add with var. You can see add with var is not even like we have not even reached the declaration line, but that's still there inside the memory with the value of undefined, and that's why you're getting this error here that add with var is not a function. But basically, you can see it was hoisted, and for that reason, the declaration at least exists in the memory, and you can access it if you want, right? Although it would have a value of undefined, that's a separate topic. Um, so yeah, but you can see here, like actually, let me go and show you this. Yeah, okay. So, but you can see I don't see A over here because A is still not declared. Let me continue here, and then you would see A as well. You can see A got added with the value of 4, and you get a console log A, right? Then you set console log B, so it will just print that. Then you can see B was already there in the memory with the value of undefined because it was hoisted. But now when I pass this line, it would get a value of 6. Okay, and then you just print that. Then here what you do, you have C already, you assign it with the value of 9 here, as you can see, and then you print that value. Okay, and then you reach this line of declaration. There it gets back the value that it has to actually get on declaration, which is 8, and then you print that value over here. By the way, the console logs are happening over here, obviously, right? Okay, then what you do is that you try to access the value of add. Now add is already there because it's function declaration, so it's already declared, so you can call that, and that would work fine. You get into a call stack of add, like basically you add gets into a call stack, and then that's done. Then you call add again, you get add into the call stack, then it's done. Again, now you declare variable add with let. Now you can see right now there's nothing like add with let over here. Once you pass this line, add with let gets there into the memory, and now you can call that function, and that should work fine. Okay, now see add with var is undefined, right? And so you can't really go and call this function, which is why we got this error, but at least you can access the value that gives you undefined over here, which is what we expect from looking at the memory, right? And then after that, we click again, and the add with var gets a function that it has to get, and then you can call it easily and get the value properly, right? So yeah, that's how you can see with debugging, you are able to understand the difference very easily, right? You are able to understand the hoisting concept, okay? And so yeah, that's about hoisting here in of var. Now let's talk about temporal dead zone. Now this is a very important thing to discuss. Let me actually take you to the MDN page where we can talk about this. So you can see over here that temporal dead zone, or TDZ for short, basically when a variable is declared with let, const or class, that variable is set to be in a temporal dead zone from the start of the block until code execution reaches the place where the variable is declared and initialized. What that means? Let's say I go and say console log hi, console log hello. Then I go and say let a equal to 4, console log a, and I say like let's say const b equal to 5 or 6, let's say, and I bring the value of b. Now, see, the thing is that when you start the execution of this program, let's say when we start with the line 1, at that point, there's no variable called a or b in the memory as we saw. But when you have reached this line, when you have started with this line, there's something called TDZ that is there. So basically, there's a TDZ that is there, and that's called temporal dead zone. Basically, that is there when the variable has not actually reached the declaration line. So this whole thing, this whole area basically comprises the TDZ for the variable a. This is the TDZ for b, right? This is basically the duration where you can't access the value of the variable. Okay. Now, I just want to prove that TDZ actually exist, right? I have two proofs for that. Let me show you one by one. Okay. Let's go and copy this to Poker.js. Okay. And let's say I try to access the value of, let's imagine like I access the value of D or C. Now, tell me, is there any variable C or any constant C in the whole program? No, right? It's not there. If I try to do that, you can see I get C is not defined, which is more, which makes a lot of sense, right? Now, what will happen if I try to access the value of A or B? Now you might say that because variables with a or variable with let and const are not hoisted, that means if I try to access the value of a or b over here, that would basically cause the same error. But that's not true. If you do a console log a over here, you can see you're getting cannot access a before initialization. Okay, the same would happen with b, right? So let me actually go and copy this error and let me paste it over here. And the same is happening with B. So you can see that there's a difference in error between this line and these two lines. Why that is happening? That is happening because of TDZ. See, the thing is that although A has not reached the declaration line and the A doesn't exist in the memory, but still JavaScript knows that there is definitely a variable called A, right? But it's just waiting for the line at which it's declared. And that's why this whole place is called TDZ. There, you can't access the value of A or B, but still, JavaScript knows that there is a variable A or B inside the script. And that's why it was able to tell you that you cannot access A before initialization. You cannot access B before initialization. It was at least known to JavaScript, although not there in the memory, and that's why you were not able to access these. And that's one of the proof of TDZ, that TDZ actually is there. This is the TDZ zone, right? It's the temporal dead zone, okay? And let me show you another proof. Now, before showing you the another proof, I would just like to tell you about one more thing here, that the word temporal, what I mean by temporal. Now, dead zone, we understand that at this point, the variable in a way is dead, or the constant in a way is dead, right? But what is temporal? Now, the word temporal is used because the temporal dead zone doesn't depend on the order in which the code is written. Although it might seem like it depends on the order of the code. If A was at the top, it would have been I would have been able to access the value of A. But that's not true. It actually depends on the order of execution. And that is where I will show you the second proof of TTZ. Now, for the second proof of TTZ, you should have the knowledge of function. So watch that lecture if you don't have the knowledge. Anyways, let's talk about that. So see, now let's imagine I have a function over here, which I say like, let's say C, and that function basically prints the value of A. Okay. Now, if I try to call this function C, you can see it's printing the value of A as 4. Now, let me do one thing. Let me go and create a function called D over here. Now, that function prints the value of A. Let's also print the value of B. Now, again, this will be able to print it because A and B both exists after this line, basically after this line, right? After 17 line. And so it is accessible over here. And same I'm going to do over here. Let's print the value of B over here. Okay. Now, tell me one thing. What would happen if I try to print, if I try to call D over here, and if I try to call D over here? Now, you might think that when I try to call D over here, it would basically result to an error because because basically this D calls A, like basically prints A and B, which are declared after D function is declared, right? And so this would cause an error, right? And the same you will think for this as well, that because D was created before A and B, so if you try to run this, you would get this error. But that is not true. Let me show you. If I try to do this, like if I try to run this one, then it will print an error. You can see it's printing that error cannot access A before initialization, which is good, which is what we expected. But the same won't happen at the other place. Let me show you. If I call this over here, you can see it is working fine. And this is a very important thing you need to understand. This is happening because, as I said, temporal word is used because the zone depends on the order of execution, not the order in which the code is written. And that's the point. The order of execution here was that I first got the A and B variable declared or initialized, you can say, which means that I passed the temporal zone of that. This was the temporal zone of that. I passed that temporal dead zone, and then I called the D function. And that's why I'm able to access this A and B inside this D function because the temporal dead zone is over for D, for A and B. And that's why I'm able to access the value of A and B inside D, even when D was actually created when A and B were actually in their temporal zone, temporal dead zone. And that's why I was saying code order doesn't matter over here. You can see this code is clearly above that A and B thing, and it's basically in the temporal dead zone, but still it gets the value printed when you call it after the temporal dead zone ends for A and B. And that's the thing you need to understand. Okay. Now, if you do this over here, like if you try to call D over here, it would basically go and print the value of A, but it won't print the value of B. And that's again a very interesting thing because at that point, A has came out of its TTZ, but B is still inside its TTZ. So if I try to call D over here, you can see I'm getting cannot access B before initialization. This is different from this place where if I do this, you can see I was getting cannot access A before initialization. And if that was solved, then it would have printed cannot access B up before initialization because both are still in TTZ. But here I'm only getting cannot access B before initialization. That's very important and that's very interesting thing to see, right? and that's called temporal dead zone. Hopefully you understood about temporal dead zone, right? Basically, the variable exists, like not exists in the memory, but at least the JavaScript knows about that variable, right? And so it is not gonna tell you what C is not defined, something like that. It's going to say cannot access before initialization. That is going to be the error, and that is the thing. So hopefully you understood about TTZ. Now let's talk about the final thing here. What should I use? Variables or constants? Now this is a very important thing again to understand. Now obviously you guys know that if you create a variable here, for example a, and if you try to update the value of a, that will work fine, right? Here the a would be 4 and here the a will be 5. But you can't do the same for a constant. If you try to create a constant here, for example, b, and give it a value of 5, for example, you try to print the value of b, which will work fine, but you can't change the value of b to 6, for example. If you try to do that, it could cause issues. Okay, let me show you. So if I copy this Core.js, you will see that actually I don't see any error. It happens sometimes with Coca. Okay, now you can see, I now see error. I don't know why this is so buggy. Although it's a very important and very interesting tool to use, it's very easy to teach anything with it. Anyways, so you can see here that I'm able to change the value of a variable, but changing a value of value of a constant is not possible. Okay, and that's the difference between variable and constant. Okay, so seeing this, you can understand that if you have a use case where you don't want the value to change, then you can just use constant. Otherwise you can use variable, right? That's how simple it is. So you might ask, if that's how it is, that's how simple it is, then why I am talking about this? The reason why I'm talking about this is because of the things that I've seen in different code bases. See, I've seen people overusing variables at places where they can actually use constants, and that is something important. See, you can use variables and forget about constants at all. Like, just think about it. If you created a variable and if you don't want to change the value for it, then just don't change the value, right? Who is stopping you from like not changing the value, right? You have the full control. And that's where the problem happens. You might try your best to not change the value of that variable because you want it to be a constant, but by mistake you can change it. Or let's say any other developer who's working on the same repository or same code can change it easily, right? If he doesn't know about it. And that's the thing. When you're defining something as constant, first thing that you get is that you can't change the value at all. It would throw an error simply, right? So even by mistake, it's not possible to change the value. And the other developer who is reading our code also understand that he should not change the value at all. And that's the advantage with constant. I would go to an extent of saying that if you uh, if you think that the value of variable will change, then only use let. Otherwise, in every other case, use const. That's the thing I would say. That's the thing I would recommend. Okay, so that you don't get into these bugs. So yeah, that's it. That's all about the difference between let, var, and const. If you have any doubts, you can ask that in comment section below. I will see you in the next one. Bye.